Hi guys, Dr. Diaz here again. Okay, so here we go. If you remember the previous problem we did, the one with the 20 partitions, which actually is the same problem with the 10 partition. Look at this one. This will give you an example of what we got when we have 10 partitions. 0.33, 20, we got 0.3325, 30. The more rectangles or partitions you have, the closer you are to its true value. And look what happened when you go to 100. This looks like it's 0.33333, like 1/3. And yeah, this is the answer. This is the thing. The more times, the closer that n goes to infinite, the closer you will get to this true value or the area under the curve. So the more times you do it, the better it will be. But you know, it's very difficult to do this thing 100 times and add all those numbers, or 1,000, or 10,000, or 1,000,000. It's difficult. So we must have an equation that solves this much easier, which is the way we're going to do the problems, most of these. And that equation is this one. Aha! For a function f defined in the interval ab, remember a is the same as x naught. If f is continuous on ab and f of x is bigger than 0 on ab, the area under the curve of f of y is equal to f of x on ab is given by this equation. When n goes to infinite, right? Not only 100, 1,000, a million, a gazillion. When n goes to infinite, you will get it closer, or actually you will get in the area under the curve, how much it will be. So going back to that problem we did a moment ago, here it is. Aha! Let's find the area under the curve, and this is more or less how you're going to solve some of the problem. And on this interval, 0 and 1. So the first thing we have to do is look at that equation that we have for the partition. The number of you divide this into n subintervals, and here is that delta x. In this case, look here, delta x for this problem is going to be, if you remember, delta x, let me write the equation somewhere around here, delta x is equal to b minus a divided by n, where b and a are a and b, and for our problem it was from 0 to 1. So b is going to be 1 minus 0 divided by n. Aha, that's why you get this in here. So our delta x now is going to look like what? 1 minus 0 divided by n, 1 over n. How about our xi? If you remember the equation for xi was x naught plus I delta x, right? X naught, I said a moment ago, is equal to a, which in this case is going to be 0 plus I times delta x, and we already called delta x 1 over n, 1 over n. So xi is equal to I, basically, because I times 1 is I divided by n. That's why they have this equation here. For all I that it goes from 0 to n. Bigger numbers, right? So then the area is going to be what? A sub n is the sum of all those functions evaluated into delta a, into xi times delta x. And who is xi? Well, here we go to the function. If you remember, the function was, it was f of x is equal to 2x minus 2x squared, right? X, now in our case, or you're going to start evaluating this function, I inside of the 2x, right? Here it is. This is like 2x, but now it's I divided by n minus 2I divided by n squared times delta x, because you remember the equation we were looking a moment ago was, okay, sorry about that, is this one, f with the function evaluating xi times delta x, right? This is the equation we're using. So going back to that problem, we're going to substitute this into delta I, and you know what? The easiest way is to do the problem. I'm going to do it in a second so you can see it. Well, actually, let me show you how they did it, and then I'm going to do it separately in another sheet so you can see me doing it step by step and see how difficult it is, which actually you will see when we get it. So we have 2i divided by n minus 2i squared divided by n squared, right? Because it's all squared times delta times delta x, which is 1 over n. And then we go here, 2 times I, well, now you distribute the 1 over x here against this one, and the 1 over n against this one, and then if you do, let's go to the next slide. Then you have what? 2i divided by n is going to be times 1 over n is going to be 2in squared. That's what I have here, 2in squared times the summation of delta I. And here, well, this one is going to be I squared divided by n squared times 1 over n is going to be 2i squared divided by n cubed. So you take outside the 2 and the n cubed, here it is. And you have the summation of I. And now, if you remember, here's where we go with the thing we learned from the other chapters. I mean, actually, all the sections. I, the summation of I, it goes from I equal to 1 to n. The formula is what? N plus 1 divided by 2. And the other one that it says the summation of I that goes from 1 to n for I squared is what? N plus 1 to n plus 1 divided by 6. And that's exactly what they did here. You remember this 2in? Still here. And what about this fellow? The I, it goes here. N times n plus 1. And here the same thing. The 2n cubed goes here. And the I squared n plus 1 to n plus 1 divided by 6. Then, well, they do here a little bit of mumbo jumbo. I don't like the way they did it here, because I would, try to look for a common denominator or cancel whatever I can cancel. That's it. But if we go to the next slide, let's see what they did. They got this equation after they cancel or simplify everything. And then what happened? If n goes to infinite, this is the equation they end up with. And this equation they end up with, after they substitute a bunch of stuff here, and we're going to do this problem again, so don't worry guys, I'm going to do it by hand so you can see it. Okay, after they simplify and cancel some of the stuff here, let's go back to the problem. They got this expression here. That expression there, I would have done this instead of what they did. This is what they have. Lim, when n goes to infinite, of n squared minus 1 over 3n squared. I would have done this differently. I would do this, which actually in some way that's actually what they did. It's going to be n squared divided by 3n squared minus 1 over 3 divided by n squared. And why I'm doing that? Because here I can see that this number n squared cancels, and what surviving here is what? 1 over 3 minus 1 over 3n squared. But what happened when n goes to infinite? When this number in the denominator is so big, this thing tends to be 0. And this one, because it has any n, it survives, and the answer will be 1/3. That's why you get here 1/3. And that's why if you look at the table that I was showing you a moment ago, go back to the table, here, what happened when you go to big numbers, you're approaching to 0.3333, which actually is 1/3. Okay guys, I hope this helped a little bit. I'm going to do this problem by hand, or I'll probably choose another problem because you already have this one. You can practice this one and see how it works. So you will see all the things behind these crazy problems, and it helps you a little bit doing the rest problem of the homework and review. Take care. See you in a second.